All right, let's pull back the curtain on this hidden world of patterns. You know, the ones that are secretly running just about everything, from the internet all the way to your bank account.
So how does a video go viral? I mean, we've all seen it happen, right? One day a video has a handful of views and the next it's literally everywhere. Now, it might seem totally random, but a lot of the time it's driven by a surprisingly simple and, believe it or not, predictable mathematical pattern.
Okay, let's say you post a video of your cat wearing some goofy hat. On day one, maybe it's just you and a friend who watch it, so 2 views. But then you each show it to 3 more friends. By day 2, you've got 6 new views. And then each of those people shows it to 3 more friends, and bam, that's 18 new views on day 3. You can see where this is going. The numbers aren't just growing, they're exploding.
So let's break this down. How does this actually work? Well, it turns out that most of the predictable change you see in the world pretty much boils down to one of 2 super simple sequences.
This right here, this is the secret sauce behind that viral growth. Our cat video was following what's called a geometric sequence. See, each day, the number of new views was multiplied by a fixed number. In our case, it was 3. And that multiplier, that's called the common ratio, and it is the engine of exponential change.
Now, let's meet the geometric sequence's much calmer, more predictable cousin, the arithmetic sequence. Instead of multiplying, this one just grows by adding a fixed amount each time. You know, think of getting a weekly allowance of, say, $10. Your total savings grow for sure, but they grow steadily, not explosively.
And this is where you can really see the difference, clear as day. An arithmetic sequence is that steady, predictable linear growth. It's like walking up a ramp. But a geometric sequence? That's exponential. That's a rocket ship.
Okay, so why should you care about any of this? Because these patterns, they aren't just some abstract math concept stuck in a textbook. No, they are running the modern world. They're kind of like the hidden architecture behind our digital and financial lives.
And just like some users on Reddit point out, these sequences are basically the fundamental building blocks in computer science. The simplest loop that just counts from 1 to 10, that's an arithmetic sequence. But when you start to analyze how information can spread through a network, well, the number of possible paths can grow geometrically. These are the basic rules that scale up to create some incredibly complex systems.
And in finance, wow, their power is on full display with something we all know about, compound interest. Ever wonder how that really works? It's literally just a geometric sequence that puts your money to work for you. I know this formula might look a little complicated, but at its heart, all it's doing is repeatedly multiplying your initial investment by a growth factor.
Let's just walk through it. Say you put in $20,000. With a 3% annual interest rate that gets applied 4 times a year, your money is multiplied by a small amount again and again and again. After just 5 years, that steady, repeated multiplication, that geometric sequence, has turned your initial investment into over $23,000. That's the pattern at work.
All right, so we've seen how powerful these finite sequences are, but now let's ask a much, much bigger question. A kind of mind-bending one, actually. What happens if the pattern just keeps going?
Yeah, what if it never stops? This brings up a really crucial question. What happens when you keep adding the numbers in a sequence forever? If you add 1 plus 2 plus 3 plus 4 and so on, the sum is obviously just going to explode. But what if you add 1/2 plus 1/4 plus 1/8 plus 1/16 forever? Does that also just fly off to infinity?
Well, when a sequence goes on forever and you try to add up all of its terms, it's not really a sequence anymore. Mathematicians have a different name for it. It's called a series. And this is where things get really, really fascinating. And this idea leads us to a fascinating fork in the road. Sometimes when you add up an infinite number of things, the sum just flies off towards infinity. That's called a divergent series. But other times, and this is incredible, the sum actually closes in on a single finite number. It converges. This graph just shows it perfectly. See those blue dots? That represents a divergent series. The sum just keeps getting bigger and bigger, shooting upwards with no limit. But look at the black dots. They represent a convergent series. Even though you keep adding more and more terms, literally forever, the total sum gets closer and closer to one specific value, without ever actually exceeding it.
Okay, let's bring this all home. Let's wrap up what we've discovered, because we've gone on a pretty wild journey here, from a simple cat video all the way to the concept of infinity.
You know, we started with this really simple idea of just adding or multiplying by the same number over and over again.
We saw that one rule leads to steady, linear change, while the other leads to that explosive, exponential change. And then we discovered this mind-bending fact that even an infinite process can sometimes lead to a finite, totally concrete result.
And you know, this quote from a programmer on Reddit just nails it. Now, sure, it's a bit of an exaggeration, but the point is profound. These fundamental patterns are hiding just beneath the surface of so many complex systems we interact with every single day.
So, the next time you see something go viral, or you check your bank statement, or even just watch a video online, you'll see those hidden patterns at play. It really makes you wonder, doesn't it? What other simple rules are out there building the complex world all around us, just waiting for us to notice?